Jai Hind students, in today's lecture what we will do is we will try to recapitulate all the graphical situations. We will discuss each and every condition whichever is feasible and we will try to graphically interpret it. We will discuss both position time graph as well as velocity time graph for all the situations, right? And also we will discuss the importance of the position time as well as the velocity time graph, right? So we will discuss in two categories. One is the position time graph, the other one is the velocity time graph. So students, first and foremost, you must be aware of slope. Slope is tan theta, which is y2 minus y1 divided by x2 minus x1. That is the slope, right? The angle which it makes to the horizontal, the tangent of the angle which the straight line makes to the horizontal, that is known as the slope, right? It indicates whether the graph is having a large slope or having a small slope, it is steep or it is flat. So we will discuss these in detail, right? So first and foremost, before we proceed, the importance of position time graph. So what will be the slope of this graph? Y-axis is represented by position, x-axis is represented by time. So position over time, that is distance over time or displacement over time, that will give us speed or velocity. In case the body is in one-dimensional motion, then distance is equal to displacement, speed is equal to velocity. So first and foremost use is slope will give us velocity of the body. Right? This is the first and foremost use of the position time graph. Now let's discuss the position time graph in detail. It can be like this. Let's consider this graph. This is A. It's a straight line parallel to the time axis. Students, what does it represent? With the passage of time, at this instant, the body is at this position. At some later instant also, the body is at the same position. At some other instant, the body again remains at its same position. So, basically, the body is not changing its position with the passage of time. It means that the body must be at rest. It must not be moving at all. So, in this case, A represents body is at rest. Clear, students? This is A. What about this case? Like this. Consider this to be graph B. A straight line having positive slope. Uphill is the positive slope and this is downhill. That's the case for negative slope. So this is the slope. I've told you, in case of a straight line, the slope is always constant, right? You can consider any 2 points on the straight line and the slope would be same. The angle which any point on the straight line makes with the horizontal would be constant. So slope is constant. Slope of a straight line is constant. And slope gives velocity to the body. So in case of a straight line, the velocity of the body is constant. So here, the velocity of the body is constant. And students, velocity is constant. Means the body must be covering equal displacements in equal intervals of time. It must be the case of uniform motion. So B, it represents uniform motion where the velocity is constant. And velocity is constant means acceleration is 0. Velocity is constant, it suggests that acceleration is equal to 0. Right? So, this represents uniform motion. So, in the case of uniform motion, the position time graph is a straight line inclined towards the time axis. Inclined towards the time axis. Let's consider the third case. It can be like this also. Curve, right? This is suppose C. This one. It's a curve. Now I have told you, in case of a curve, the tangent is given by drawing a tangent at that particular point, right? So, the slope is given by drawing a tangent at a particular point. the slope of position time graph will give velocity. So at this instant, the velocity will be given by tangent. This is the velocity. At this point, this is the velocity. At this point, this will be the velocity. So what I mean to say is that you can check the slope of this graph is increasing with the passage of time. So velocity is not constant. Actually, velocity is increasing. The slope is increasing with the passage of time. It means that velocity is increasing at a constant rate. So it is the case of uniformly accelerated motion. So C represents velocity is increasing at a constant rate. So it is the case of uniformly accelerated motion. Again I repeat, students, in case position time graph is a curve, then the slope of position time graph will give us velocity, and the velocity at any point on the curve will be given by drawing a tangent at that particular point. So here you can see the slope of this graph would be like this. Here it will be like this. Here it will be like this. So with the passage of time, it is becoming more and more steeper. Means the slope is increasing. Slope is increasing means velocity of the body is increasing. And whenever the velocity increases at a constant rate, it must be the case of uniformly accelerated motion. Clear? So graph C, it will represent uniformly accelerated motion. Now let's consider this particular graph like this. This is suppose graph B. Graph B. Now this is the graph, position time graph. Again, as I've stated, the slope of position time graph will give us velocity. So here let's see, initially this is the slope. This is the slope. Here the slope is like this. Here the slope is like this. Here the slope is like this. So you can easily check with the passage of time, the slope is decreasing. That is, the curve becomes more and more flat. That is, the slope of the graph is decreasing with the passage of time. Now since slope gives velocity, therefore this is the case where the velocity is decreasing at a constant rate. So here velocity is decreasing at a constant rate. Velocity is decreasing at a constant rate. So whenever the velocity decreases at a constant rate, it is the case of uniformly decelerated or retarded motion. So it must be the case of uniformly decelerated or retarded motion. Right, students? So these are the four possibilities. Again I repeat, A is a straight line parallel to the time axis. This represents that with the passage of time the position of the body remains same. So that must be the case when the body is at rest. Second one is a straight line. Now straight line, the slope of a straight line is always constant. Position time graph, its slope gives us velocity. So a straight line represents velocity of the body to be constant. And whenever the velocity of the body is constant, it means that it must be the case of uniform motion, when the body covers equal displacements in equal intervals of time, right? So this straight line, which is graph B, that represents uniform motion. Consider this graph C. This one is a curve like this. In this case, the slope of the graph keeps on increasing with the passage of time. Slope increasing means velocity increasing. So therefore it must be the case of increasing velocity of the body. So that is known as uniformly accelerated motion. Consider the last case, this one. This is the graph like this. The graph is flattening out, right? With the passage of time, the slope is becoming less and less. That is, it is becoming flatter. Earlier it is quite steep. Now it has become flat. So as a result, slope is decreasing. Means it is the case where velocity of the body is decreasing with time. So it must be the case of uniformly decelerated or retarded motion. Right? Similarly, let's consider velocity time graph. First and foremost, we need to understand the importance of velocity time graph. Slope is y2 minus y1 divided by x2 minus x1. So in this case, change in velocity divided by the time during which that change in velocity has occurred. So change in velocity divided by time, that is known as acceleration. So in this case, first important point is slope will give acceleration. And second important point, area under VT graph, we are aware of it. Area under velocity time graph, it will give us displacement covered by the body between the two given intervals of time. So here the slope of position time graph gives us velocity. The slope of velocity time graph will give us acceleration. And the area under velocity time graph will give us the distance or displacement covered by the body between the two given intervals of time. Area means, just find out dimensionally. Area means velocity multiplied by time. So its unit is meter per second, its unit is second. So we'll be left with meter, which is the unit of distance or displacement covered by the body, isn't it? So area under VT graph gives displacement covered by the body. Now let's check it out. This is A. What does this graph signify? With the passage of time, at this instant, the velocity is supposed 10 meter per second. At some later instant, the velocity of the body remains 10 meter per second. At some other instant, the velocity of the body still remains 10 meter per second also. So this graph A represents velocity to be constant. Velocity is constant. And whenever velocity is constant, it must be the case of uniform motion. It is the case of uniform motion. Right? That is, in this case, the body covers equal displacements in equal intervals of time. So, if the velocity is constant, so acceleration would be 0. If there is no change in the velocity of the body, then obviously acceleration is 0. Right? Second, B. Suppose the graph is like this. It can pass through the origin as well. If it is a straight line passing through the origin, it means that the initial velocity of the body is 0. In case the graph is like this, so this will be the initial velocity. This will be the initial velocity. Right? It will possess some initial velocity in that case. Okay. Here look, it's a straight line. So slope is constant. Slope of velocity time graph will give us acceleration. So it suggests that acceleration is constant. Right? And it is uphill. So it is the case where A has positive constant value. So it is the case of uniformly accelerated motion. A is constant means it is the case of uniformly accelerated motion, where the velocity of the body increases at a constant rate. Right? So this is B, which represents constant acceleration, and acceleration must have positive constant value, which further suggests that the body must be in uniformly accelerated motion. It can be like this, C. Now look, this is again a straight line. So again acceleration is constant, but in this case, the velocity is decreasing at a constant rate. It is downhill, slope is negative. So here, acceleration, the slope of VT graph will give us acceleration, and slope is negative, means acceleration is negative. So it is uniformly retarded motion. So here, again, acceleration is constant because it's again a straight line. But here, A will be having negative constant value. So it must be the case of uniformly retarded motion or decelerated motion. It is the case of uniformly retarded or uniformly decelerated motion. Right, students? And in case it's given like this or like this, curved, in case it is given by curve, then it must be the case of non-uniformly accelerated motion. It must be the case of non-uniformly accelerated motion. Right? In this case, the slope is increasing. The slope is increasing means acceleration is increasing. Acceleration is not constant. And if acceleration is not constant, it suggests that it is the case of non-uniformly accelerated motion. It can be like this as well, like this. Suppose it is D. So, suppose it is E actually. We have represented D by this. So, it is E. E also represents the same thing. Non-uniformly accelerated motion. So, in the case of VT graph, if the graph is not a straight line, it's curved, then it must be the case when the slope is not constant, that is acceleration of the body is not constant. And if this acceleration of the body is not constant, it means it must be the case of non-uniformly accelerated motion. Clear, students? So these are the conclusions which we can derive from these two very, very important graphs. So do revise this topic thoroughly, and if you have got any doubt, you can text me or directly you can call me to clarify your doubts. Right, students? Okay, I hope you will revise this topic and do all the numericals in your textbook and do some additional questions from reference book as well. Thank you, students. All the best.